students, welcome back to the series of lectures of Intermediate 1B. Today I am going to discuss with you the same exercise 9C which we were dealing in so many videos. The same exercise, the continuation part till fourth section, the fourth bit of the section 2 I had completed in my previous video session. That just click on the iCard and you will be notified, and the remaining problems or remaining exercise of differentiation chapter, there are 17 video lessons. Those you can check it in the description below, either or else you can see the channel playlist wherein you will find all the lessons. So the links will be provided in the channel playlist. You can be notified. Now here in the continuation part, the fifth problem. So in that here, fifth problem, the first bit was covered in the previous class. Now the second one, if here establish the following is the heading there. If y equal to given this big function, then we need to prove dy upon dx is 2 root a square plus under root a square plus x square. So with this big function, let us start the differentiating with respect to x. So dy upon dx is equal to, here if you see two functions, x multiplied by under root. So let us do u and v product. Okay, so x, that is u, and differentiating v. Okay, so differentiation of this is 1 by root a square plus x square, as you know. Yes, and again this is not the x function, we have to do the derivative of a square plus x square. So a square is 0, x square is just 2x according to the chain rule, plus u v dash, and again here v we will write u dash, that means x differentiation is just 1, plus we need to differentiate this also. This is a constant, I can take it out, and for the log function differentiation is 1 upon x under root a square plus x square. So log of x is 1 by x, isn't it? Again with the chain rule, again we have to differentiate this, right? So multiplied by differentiation of x is 1 plus differentiation of this is 1 by 2 root a square plus x square. Yes, but again we have to do the again according to chain rule, we have to do the differentiation of a square plus x square, that is 0 plus 2x, so that is just 2x. So here 2 and 2 goes off, and that's all. Even here 2 and 2 goes off. So we have, what do we have? Dy upon dx is equal to, we have x into x, that is x square plus under root a square plus x square, plus here again under root a square plus x square, plus here let us do the a square plus x plus under root. Let's do the LCM part inside the bracket first. Okay, 1 plus this one, so we will do the LCM here, root a square plus x square. So here a square plus x square plus just x. Okay, and here if after doing the LCM, this is multiplication, isn't it? So this part and this part gets cancelled off, we get x square a square plus x square plus under root a square x square plus only this over this, that is a square plus x square is remain. So here you can club these two, that comes to x square plus a square upon a square plus x square. Yes, plus under root, here root is there, a square plus x square. This is what dy by dx. Still further we have to get this 2 under root of a square plus x square. So that means if you do the LCM only, the same thing comes here. You can write it here. Okay, a square. So here you can cancel these two, you get just here. If I cancel out, you can write this as x square plus a square whole square, isn't it? Whole square under root, I can write that. So a square plus x square, just you can cancel off 1. This I can write it as x square plus a square, so I can cancel off this complete thing. If you cancel off, you get 1 square root, isn't it? Just wait, I'll make it simpler. So this becomes a square plus x square multiplied by again a square plus x square. I can split this into 2 square roots. Okay. So 1 square root, we will cancel it off. Plus there is another square root. Right. So we have these two. Okay, we have these two. So that equals 2 square root of a square plus x square. So finally we got what? Dy upon dx is equal to 2 square root of a square plus x square. So just I have split this into 2 square roots because square root whole square becomes the same thing. So 1 square root gets cancelled. We have 1 square root and 1 square root, that is 2 square root of a square plus x square. That is what we have to prove it. Okay. Pause it and note it down. The third problem here, if x raised to the power of log y is equal to log x, then dy upon dx is equal to y by x, and this part here. Here we have to start with this and we have to prove this. When log functions are there here already, but we have an exponential function, something to the power. So again we need to apply the log. Okay, applying log both sides. Apply log both sides. Here, see here, to this side and this side, that means, let me write here, log x raised to the power of log y equals to log of log x. Since there is exponential, I am applying log. So this power comes before log y. Log x is equal to log of log x. Okay, so this is the function. Now differentiating with respect to x. Differentiating with respect to x, we will find here uv function is there and here there is only one function. So here u and v function, let us do u log u into dy by dx of d by dx of log x is just 1 by x, right? Plus again we write it and log y, that is 1 upon y, but y is again there, so we have to find it according to chain rule. We should differentiate it, is equal to uv method I've used, and here again this is 1 by log x. Okay, log of something, so 1 upon log x. Again we have to differentiate log x, that is 1 by x simply. So what we will do, we will bring this to this side. Okay, so shift this to the other side, that becomes, okay, let me write it here, log y upon x is equal to plus log x upon y dy by dx is equal to 1 upon x log x. Okay, so keep this to this side, shift this to the other side, so that becomes log x by y dy by dx is equal to 1 by x log x minus this part log y by x. Let's take the LCM to this side first. X log x is the LCM, so here 1 minus x is already there, so log x log y. Okay, just taken the LCM here, and here log x divided by just y. This, if you shift, it becomes a reciprocal. So we have here dy upon dx is equal to, shift this to the other side, that becomes y by log x multiplied by the whole thing, 1 minus log y log x divided by x log x. Yes, so according to this, if you want to write it in this way, bring this x to this side and log x to the inside. Okay, y by x is equal to 1 minus log x log y. You can write it like this. So log x whole square. Okay, this is the required thing, right? Pause it and note it down. The fourth problem, if y equal to tan inverse of 2x by 1 minus x square plus tan inverse of 3x minus x cube by 1 minus 3x square plus tan inverse of 4x minus 4x cube 1 minus 6x square plus x raised to the power of 4. Then we have to find dy by dx is equal to 1 by 1 plus x square. See here clearly, here 2x by 1 minus x square. This is likely in the form of tan 2 theta. This is in the form of tan 3 theta. And this is in the form of tan 4 theta. Although you don't know the formula, that was not there in the intermediate. Here this is the tan 4 theta formula. When we are getting the inverses, we need to reduce these equations into trigonometric ratios so that the inverse and the tan gets cancelled. Okay. So let us take here, let x equals to just tan theta. So here it will be reduced to y equal to tan inverse of 2 tan theta 1 minus tan square theta plus tan inverse of 3 tan theta minus tan cube theta. I am substituting tan theta in place of x. 3 tan square theta plus tan inverse of 4 tan theta minus 4 tan cube theta divided by 1 minus 6 tan square theta plus tan 4 theta. So this formula is not there for your class, but that is tan 4 theta formula. Okay. So this can be reduced to tan inverse of, this is tan 2 theta formula. Right. Similar way, this can be reduced to tan inverse of tan 3 theta formula plus tan inverse of tan 4 theta. Okay. Still we are not doing the derivative, but just we are substituting into the trigonometric ratios formula. Tan inverse tan goes off. Simply we get 2 theta plus, here let me check in the textbook, all are plus, just this part is minus. That's what I got it out. This is minus in the question itself. Okay. This is plus, this is negative sign. So plus 3 theta minus 4 theta. Okay. This is minus 4 theta. Because tan inverse tan reduces. Okay. Y is equal to 5 theta minus 4 theta is just theta. Now we know what is theta. Y is equal to what we have put, x is equal to tan theta. This if you shift it, it becomes tan inverse of x. Now we will do the derivative with respect to x. Dy by dx is equal to, what is the derivative of tan inverse x? 1 plus x square. This is our answer. Okay. Pause it and note it down. Fifth bit, that is, if x raised to the power of y is equal to y raised to the power of x, then we have to find dy by dx of this function. Okay. And the sixth one also I have noted down. With this, the section, in this, the fifth bit, all the 6 problems will be covered. Here, if you are taking this, starting with this, these are again exponentials. We need to go by applying the log. Okay. So let us apply log both sides. Apply log both sides. Okay. Here, so log of x raised to the power of y is equal to log of y raised to the power of x. So just to bring the exponent to front, we will be applying the log. Okay. Here, y log of x is equal to x log of y. Now differentiating with respect to x. Okay. So u and v product rule. So let us start. U, differentiation of v is 1 by x plus log x into differentiation of y is dy upon dx is equal to, again u and v product rule. x, differentiation of log y is 1 by y, and again dy by dx since the function is in y, plus log of y, differentiation of x is just 1. Here what we will do, we will simplify it, y upon x plus log x dy by dx is equal to x upon y dy by dx plus log y. We will bring all the dy by dx terms to one side and the rest of the terms to the other side. So dy by dx, and let's take the common here. So log x, if you bring this side, this becomes x over y equal to log y minus y over x. Let's take the LCM both sides. Here LCM is y log x minus x equal to, if you take the LCM here, x log y minus y. Okay, this side LCM and this side LCM. Yes. Now we want dy upon dx. This to the other side, it becomes x log y minus y by x multiplied by y. So dy upon dx, this if you go to the other side, it becomes reciprocal to log y minus y by x multiplied by y log x minus x, right? So this is what we wanted. We will write it in the simplified form here. Y into x log y minus y, yes, by x into y log x minus x, right? So this is the dy upon dx final answer. Now moving on to the sixth problem. If x raised to the power of 2 by 3 plus y raised to the power of 2 by 3 is equal to a raised to the power of 2 by 3, then dy by dx is minus cube root of y upon x. So let us start with this differentiating, okay? We will do the differentiation here. Differentiating with respect to x, okay? So what differentiation of this becomes 2 by 3, yes, x raised 2 by 3 minus 1. So that comes to, see here, let me write n x n minus 1, 2 by 3 minus 1. Okay, that is nothing but minus 1 by 3, right? So let us write it as it is again. Plus, here 2 upon 3 y raised to the power of minus 1 by 3. Again the function is in x, so we have to write dy by dx. Now differentiation of a raised to the power of 2 by 3 is just 0 because it's a constant. Now this becomes here, if you take, let me take this, so 2 by 3, if you shift this to the down, dy by dx is equal to, bring this to the other side, that becomes minus 2 by 3 x raised to the power of 1 by 3. Keep it down, so the negative sign goes off. Okay, now we want dy by dx is equal to minus 2 by 3 x raised to the power of 1 by 3 multiplied by 3 y to the power of 1 by 3 by 2. This to the other side reciprocal. So you can cancel off 2 and 2 and 3 and 3. So minus is left over. Y raised to the power of 1 by 3, x raised to the power of 1 by 3. So this is clearly the cube root. This is in exponential form. You can write it in cube root, minus 3 cube root of y upon x. So this is what we need to find it. So with this we have completed this part, that is the fifth question of this exercise 9C. Pause and note it down, and with this we will end the class and we will see the remaining problems in our next class. Thank you all.